All right, I'm going to share my screen. There we go. Okay. All right. Today we're going to move on from our last week discussion. So let's remind ourselves what we are in the business of doing. Last week, we're kind of like developing some of the basic terms and the basic kind of indicators for an economy. It's kind of like an analogy I like to use in terms of what we're doing is like if you think about medicine, an analogy with a doctor. So if you go to a doctor, the doctor is trying to assess the overall health of a complex system, which is your body, which is essentially the interaction of billions of cells doing complex tasks. And so what the doctor is going to do is not going to look at each one of those cells individually and see how they're doing, but he's going to look at a few indicators of your overall health. He may look at what is your blood pressure. He may look at what's your weight relative to your height. He may look at what's the, do a blood test and see what's how much cholesterol you have, blood sugar, whatever. So there's going to be a few indicators that summarize a lot of information about the health of a human body. And here we're kind of doing the same thing. We have a complex system, which is an economy, and we're going to be trying to get a few indicators that summarize what's going on in the economy. In a way, kind of condense all of these complex interactions that all of these firms, so this kind of like people, households, and firms, interactions, government, and at different levels and so on are having, summarize that in a few numbers that give us an idea of what's going on. And last week, we were focusing on the idea of summarizing what's going on with the size of the economy in terms of production. And we talk about the notion of gross domestic product, which essentially summarizes in one number how much is the economy producing. And we talk about two flavors. We talk about nominal gross domestic product and real gross domestic product. Nominal is in dollars. When we're comparing dollars quantities over time, we have the problem that the nominal GDP may be going up because prices are going up and not because the economy is producing more. And so when we want to focus on how much stuff is being produced, we use a measure of real GDP, which essentially keeps the price level fixed in some way and focuses on the growth of production, okay? And similarly, we sometimes we want to also have one number that summarizes all that is going on with the price side of the economy, okay? And so one number that summarizes information about prices is referred to in economics as a price index. And there's a lot of different price indices depending on what subset of prices in the economy you're focusing on. We'll look at a few examples of price indices today. So the first price index, kind of mentioned it last time, comes from our discussion of nominal and real GDP that we had last time. So if you remember, we said nominal GDP can be growing because quantities are growing or because prices are going, and then real GDP is what's happening with quantities. And so what it follows is that the difference between how much is nominal GDP growing and how much real GDP, the gap between those two has to be because of the growth in prices. And so we can define simply the ratio between nominal and real GDP as an overall measure of what's going on with prices. And for example, if nominal GDP is double than real GDP, then the price deflator will be equal to 2. That means that prices have roughly doubled. So you can see that this price index is going to be the implicit price deflator, or just price deflator for short, is essentially capturing, in some sense, the average percentage increase in prices. And we see that's common unit used for price indices. Typically, we express price indices in a unit that we can read right away what was the percentage increase in prices, because as we will discuss later, that's essentially what we're ultimately interested in, not necessarily the value of the prices, but the growth rate of the prices, okay? Now, once again, I see somebody wrote on the chat. Okay. All right. So for example, if the deflator will be 1.5, that will mean prices on average grew 50%. So sometimes, to emphasize that, we multiply the price deflator by 100. So instead of saying the price deflator, which is a ratio between nominal and real GDP, is 1.5, another way of saying that is nominal GDP is 50% bigger than real GDP. Another way of emphasizing that, rather than saying 1.5, we multiply by 100, so we get 150. And that 50 is in percentage units, so we can read in percentage terms right away. As we'll see, that's a change of units that sometimes is used in other price indices as well, okay? Obviously, if prices didn't change over a period of time, then nominal and real GDP are equal, and then P, the deflator, will be equal to 1. Why is it called deflator? Well, because just from the definition, if you think of nominal GDP, if you divide by the deflator, so the deflator being a number bigger than 1 is how much you have to shrink nominal GDP to get real GDP. So in other words, how much you need to adjust nominal GDP by the growth in prices. So another way of thinking about this is like, I know nominal GDP is growing because the quantity produced has increased, and also because prices has increased. And so now I want to shrink nominal GDP by a factor in order to eliminate the growth in prices and only focus the growth in quantities. That factor is the deflator, okay? So those are kind of like different ways in which we interpret this first price index that just follows from our ideas about nominal and real GDP. Now, what is the kind of problem with this measure? The advantage is kind of relatively simple. You just need, once you have your data for nominal and real GDP, you just divide them and you get the deflator. Now, the problem is that, remember, gross domestic product is a measure of all goods and services produced in the economy. And so that may include goods that are pretty random, like if an economy is producing enriched uranium for its nuclear plants, or if an economy is producing, complex metals for manufacturing cars or for their, whatever. All of these goods will also be included will have an effect. So let's say there was a big increase in the price of uranium, then that would push the deflator up. But most likely that will not have a direct effect on most consumers. And so for that reason, the price deflator is a measure of what happened in the overall, all goods and services produced in the economy. Obviously, not all goods and services are going to have the same weight. The weight is given essentially by their share in total GDP. So goods that are important to total GDP in terms of their share, what happened to that price is going to have a bigger effect relative to goods who have a smaller share in terms of real GDP, total GDP. So, but essentially, it's going to be influenced by all goods and services produced in the economy. So sometimes what we want is to focus on prices. So we're going to only look at subset of goods and focus on those goods prices and services that are relevant to what happens to consumers, to the average consumer in an economy. And that's what the consumer price index is going to be about. It's going to be about what's going on when we look at a subset of goods that are the goods that are relevant to the typical consumer in a society. So it's sometimes a more useful measure of cost of living in a society, okay? Because there might be some goods and services that are completely irrelevant for the average person. And so what happens with those prices is not going to have a direct impact in the cost of living for families, okay? So how do we do this? Essentially, what we do is we pick a set of goods that we call a representative basket of the goods and services that typically a person consumes, and we look at how the cost of that basket changes over time, okay? And so this basket is what we call the representative basket, and we look at how this basket changes. Now, obviously, this introduces a problem because by keeping the basket fixed, we're not allowing consumers to do something very basic, which is that if let's say in a representative basket, people were eating, you know, whatever, 2 sticks of butter per week, and now let's say for whatever reason the price of butter goes up a lot, people are going to substitute butter for olive oil or for a cheaper product. And so by keeping the basket fixed, in a way, we're overestimating the effect because we're of the increases in prices, because we're not kind of considering the fact that consumers will substitute away from prices, from goods that prices are going up significantly. Okay, but it is still a measure. It has some limitations that that I described, but it is it gives us useful information anyways. So just to fix ideas, let's do a simple example. So let's say we have the expenditure for the typical household of 60 hamburgers and 4 t-shirts. And let's say the prices in 2010 of 60 hamburgers and 4 t-shirts was $5 per hamburger, $15 per t-shirt. So the total dollar of this basket of 60 hamburgers and 4 t-shirts in 2010 would be $360. Okay. Now, to compute the CPI, now we want to see what happened to the prices of hamburgers and t-shirts 6 years later. Okay. So let's suppose that 6 years later, in 2016, the basket is still going to be 60 hamburgers and 4 t-shirts, but now we see the price of a hamburger has gone up to $6. The price of a t-shirt has gone down to $13. The overall cost of this basket of 60 hamburgers and 4 t-shirts now is $412. So we could say that the CPI in 2010 was 360, and now the CPI in 2016 is 412. But as I said, those numbers, they're useful, but sometimes we're more interested in a number that we can read immediately what is the percentage increase. And so to do that, normally what we do when constructing the CPI is to write down the CPI in terms of a percentage increase relative to some base year. And so if we consider, for example, the base year to be 2010, then we would look at the CPI in 2016 as how much did the cost of this basket of 60 hamburgers and 4 t-shirts, what was the percentage increase relative to the cost of 60 hamburgers and 4 t-shirts in the base year, which is 2010. And so in our case, the answer will be basically the 412 over 360 times 100. Now notice this is the gross growth rate, which means if we want to have the growth rate, we have to subtract 100. So we see basically what this is telling us is that the CPI in 2016 is 114.4. That means that relative to the base year of 2010, the cost of the representative basket of goods has increased by 14.4%. And so that's why we, instead of just saying the CPI is 412, we say the CPI is 412 over 360 times 100. So we can read right away the percentage increase. By the way, by this definition, the CPI in the base year will always be equal to 100, okay? Instead of 100, sometimes this multiplying by 100 is simply, so we can read this as percentages. We may eliminate the 100, in which case the CPI will be 1.144. The same thing as we did with the deflator, it could have been 1.5 or 150. We multiply by 100 to be able to read percentages easier. but sometimes you may see a CPI without this times 100. So in that case, the base year will be equal to 1. So in other words, we can express the CPI in percentage terms or in decimal units. And either way, it has advantages and disadvantages. Does that make sense? Is there any questions so far? Okay. Now, it's important to make that comparison with real GDP. When we were doing real GDP, we had the value, we were interested in the market value of goods and services. Hello? The market value of final goods and services. And so we were keeping prices fixed from a base year and seeing what happened with quantities, because our goal is to see what happened with production, with the value of production over time, net of prices. Here, when we're constructing a price index, we're doing the opposite. We want to know what happened with prices. And so we're keeping quantities fixed. That quantities is what we call the market basket. So we're also only looking at a subset of goods. And I posted a link on Canvas in which you can go to the, for example, the Statistics Canada has a webpage for the Canadian CPI, and you can look at what type of exact weights, different things, but some of the things included in the representative baskets include obviously transportation, housing, entertainment, like, going out to restaurants, food, energy, like gas, things like that. So there's different. Now, the same problem we had with the real GDP when we hold prices fixed over a long period of time happens with quantities, which is the representative basket may need to be adjusted every now and then to keep track of the fact that new goods may enter the economy and things like that. For example, the representative basket in the 1990s probably didn't include a smartphone, didn't include an iPad, didn't include all sorts of things that now are kind of important. So that's one other issue that statistical agencies have to deal with when they are actually doing this for real economies in the real world. All right. Now, quick question to see if we got the basic ideas here. Suppose that no prices changed between 2010 and 2016, but our typical family in the previous example bought 20% more hamburgers and 20% more t-shirts. What would be the effect of CPI in 2016? If you answer in the chat, I cannot see the chat, so you have to use your voice.
Increase.
Increase by how much? You think if you go to a job market interview, you're going to be able to answer your questions by chat? So somebody's asking a question here in the chat now. Once again, this is a Zoom class, so this means it should be even less scary for you guys to ask a question. This is a great question somebody asked there. Why was the CPI in 2010 100? It really frustrates me that people don't ask those questions out loud. So I want to encourage you again, please ask those questions out loud. What I said, if we go back to the definition, so let's go back to why was the CPI in 2010 100? Essentially, as Taya Gill, I'm sorry if I'm mispronouncing your name, answers, this is just a way of which we change units. So remember, the CPI is just telling you what was the percentage increase relative to the base year. So if the CPI is 120, that means that relative to the base year, the cost of the basket has increased 20%. So it's not telling you what's the cost of the basket, but it's telling you what is the percentage increase relative to the base year. which means that relative to the base year, there's 0% increase, in which case the CPI should be 100. Now, the cost of the basket in the base year is 360, but we are expressing it in different units. That's why it's called an index. So it's not consumer price, but it's consumer price index. Index means it's expressed in a different unit or unitless at times. And so that's what the term index comes from. It's a number that gives us information about the prices, but it's not necessarily in units of dollars, but it's in units of growth rate. And so 100, if you look at this definition here, is the cost of the basket in 2010 divided the cost of the basket in 2010. So this will give you a 1 and multiply by 100. It'd be the number you get for the base year. So once again, a number of 100 just means the cost of the basket hasn't grown at all. Does that make sense?
So I had a question.
No, hold on. Does that make sense?
Yes.
No, not to you, Ivan. I am asking to Elijah Mabudi.
Yes, that makes sense. Thank you.
Okay, thank you. All right, then, Ivan, you had another question. Go for it.
Yeah, so I was wondering about like, so what base year would like the real CPI use?
Whoa. There's no real CPI. There's just CPI.
No, like the current, you know how like they print like CPIs in like every month or something? Like what base
Yes.
year would they use?
Well, different countries may use different ones. So let's see. This will be a good time to come to our Canvas web page. But I'm gonna have to share again. I don't know where I can just share my screen, period. I have to share. Okay, so if you come here, so here you have the Consumer Price Index portal for Statistics Canada. And if you come here, it will explain in detail. It has some places where it actually it may explain exactly the weights of different categories. But here, let's see, they have the data here. So here we have the way it's expressed here is at a percentage change relative to 1 year before. Okay. And then so here what we can see is the inflation rate or the percentage increase in the price level relative to 1 year before. And you can see things were about the order of 2%. Then during COVID, things went down to negative inflation or deflation, and then went up all the way to 8%, and now it's settled around somewhere between 3.5% and 4%, more or less. Now your question will be more looking at, wait, not here. Look at this one here. This is typically presented as change. Oh, here it is. No. Okay. I can't seem to find a graph for the actual CPI, for which I apologize. Should be somewhere here. So here you have, for example, what the representatives are. Here. See, that's one important message from this, for which I apologize because I was hoping I was going to be able to answer your question of which year is taken as the base year. Maybe here is that most likely the CPA is rarely presented in values, and it's more often presented in percentage changes. Now, why is that? Because the CPI will give you information of what was the inflation relative to the base year. The base year may be 2003, but we're more interested perhaps in what's going on with the inflation relative to the last year, in which case we do have to look at the percentage increase in the CPIs. Let's see if we can, if it's here. I'm sure they have it somewhere. Oh, here it is. So instead here, so here you just put it as index. See, that's another reason why it's often not put as index, is because it seems, so here I can answer your question. 2002 is the base year. Okay, so I was able to answer your question. You can also see it's kind of hard to read here what's going on. If you look at it, it all seems pretty flat. All you can see is here there's been about a 40% increase in prices between 2002 and whatever 2021. And then if you look at here at the last point, now you see it's been a 58% increase. But then the question is, how much has prices increased between January 24 and January 23? And for that, you got to look at the growth rate between this value, 153.9, and well, I guess we don't have the data for January yet, but that will be for December, whatever that value is. So that's what this will give you, okay? This tells you the 1 year percentage change. And so this is more often how data is presented, but you don't really need to know what the base year for this, but here you can see the base year is 2002. Okay. Sometimes we can expand this a little bit more. And now you can see there's been a growth rate, and you can find 2002, that's where this number would be 100, more or less. Okay. So this gives you more like the historic trend. But this is just see an upward trend, but you can't really see what happened where presented as inflation. You can see, for example, the 70s were a period of high inflation, much higher than now. And then we have a period of pretty stable growth rate in prices of about 2%, all the way from the 90s, all up to the COVID rebound here. And so that's why a lot of people started comparing the current situation with what happened in the 70s. Even if we expand for all the 70s, you'll see 70s were a period of high inflation in the order of 13, 15% per year.
Okay, so when they mean 12% or 12-month percent change, is that like moving? So like if it
Yeah,
goes
that's a
from
moving. So that's moving. So what they do is they look at the CPI in December. So here, this data point here, for example, June 2022, what they look at is look at the CPI index for June 2022, and then look at the CPI index for June 2021, and they do the new minus old over old formula to compute the percentage change, and that number is 8.1.
Oh, okay. Thank you.
Okay, so that gives me a chance to show you. You can explore that webpage a lot more if you want. I just wanted to show you a little bit. Okay.
Professor,
Yeah.
in the previous slide, the numbers were different. Like here it's 114.4, and the box below it's 14.4.
No. 412 is the cost in dollars of the basket of 60 hamburgers and 4 t-shirts, but that's not the price index. The price index is the percentage increase relative to the base year. The cost in dollars in the base year was 360. So the CPI is this number, 412 divided 360 times 100. So it gives you 114.4. Or you can interpret this number as telling you the CPI, the cost of a basket has grown in 2016 relative to the base year 14.4%, which is this 114.4 minus 100. So if you subtract 100 from the value of the CPI, you get the percentage increase relative from the base year. Does that make sense?
Yeah, CPI minus 100 is percentage increase from base year.
From the base year, correct.
Okay,
Now,
thank
as I was saying here, just because you bought 20% more hamburgers and 20 more t-shirts, it doesn't mean the CPI changed, because remember, we're keeping the basket fixed at 4 hamburgers, at 4 t-shirts and 60 hamburgers. So if the prices didn't change, the CPI would not change. It's not a matter what people end up actually buying. That's an important thing to notice. Now, we look at Statistic Canada. For the US, this is done by the Bureau of Labor Statistics. It collects data on a lot of goods that are relevant to consumers. You can explore the links and you can look at which goods are included and the weight and all of that. Now, as I was discussing a moment ago, sometimes the CPI, so the index is not so relevant, because maybe, as in the case of Canada, the base year is 2002, and we don't care about what's the inflation, the 20-year inflation, or how much prices have increased in 20 years. So what we do is we compute the yearly inflation by looking at the percentage increase in the CPI. And so, for example, if we have 2 CPI measures 1 year in a row, the CPI is typically measured in a monthly basis. So let's say this is January 2011 and January 2012. Then we know that relative to the base year, there was 124.9 inflation in 2011, and relative towards the base year, there was a 129.6 inflation. But the question is, what was the inflation between 2011 and 2012? That's called the yearly or 12-month inflation. And that's just looking at the percentage change. So we can say, oh, this one was 2.1%. So that's the difference. This number is what was happening when I was clicking on 12 months percentage change. It gives you the yearly percentage change, which is called inflation. So that's the definition of the world of the way economists call the percentage change in the price level is called the inflation rate, which just means how much prices are growing on average. So the only difference is this is a yearly measure, whereas this one gives you information of the percentage change relative to the base year. So it's over many years. So most likely, as you encounter, information will be presented in a yearly basis, not on a relative to base year basis. Does that make sense?
Yes.
Okay. All right, so a little bit of terminology. Positive inflation means the price level is rising. Negative inflation means the price level is falling. And then we could have a situation like we just actually going through right now, which is if we look at 2022, inflation went up to 8-9%. Now we're down to a positive but lower inflation of about 3%. So now we're going through a period of disinflation, which means we still see price level rising, but it's rising at a lower rate. Okay. And then, so this period here, for example, of the 1980s was a period of disinflation. This is basically the same figures that we looked at for Canada, but for the US. You can look at this from the Federal Reserve webpage. They have a lot of data there as well. I think I have the link on Canvas too for you guys to check it out. You can see something similar here where you see the 70s were a period of high inflation in the US, and then things kind of come down in the 80s, and then from then on, all the way in the 90s, all the way to COVID, things were pretty stable in terms of inflation. So here you see, once again, the long post-World War II inflation series. You see after World War II, there was some, coming down from the war inflation. then things were more or less flat. Then we have the 70s. In the 70s, there was the price of oil went up a lot. And so this was a period of high inflation. And things stayed stable at about 2%. We had a period of deflation here in the 2008 crisis. And then if you keep following forward, we'll have a period of deflation during the COVID crisis, and then a period of back to high inflation, unlike we haven't seen since the 1970s. So that's why a lot of economists started talking about like, okay, things starting to look like the 1970s. We haven't seen this since the 1970s. All this talk about the 70s have to do with this, okay? So periods when the US experienced deflation, one here, one here. When prices were rising the fastest was probably here in the 70s, this peak in the late 70s, early 80s. And then this inflation was period like here in the early 50s or here in the early 80s where the inflation rate started to come down. Okay. All right. So just to summarize, the CPI is a measure of the general price level that is price levels that are relevant for the typical consumer. It calculates the cost of a market basket of goods relative to the cost of that basket in some base year. It's constructed by Statistics Canada in Canada and by the Bureau of Labor Statistics in the US. And it's used to calculate the inflation rate, which is the percentage change on a yearly basis of this index, if you're interested in yearly inflation. You can compute monthly inflation rates. If you are in a country like Argentina, where inflation rates are high, then sometimes you do get reports of, the higher the inflation rate, the more you tend to get inflation reported over shorter time periods. So in Argentina now, at one point, they started reporting the inflation on a daily basis. That's very bad news. It means prices are growing very quickly. All right. Okay, so we kind of define the idea of inflation, and we define the basic of a consumer price index. Now, let me say there is not one measure of inflation, but there's many different measures of inflation. Because depending on which price index we use, we may use the deflator. The deflator, as we said, is influenced by all goods produced in the economy. You may get a different inflation that if you look at the consumer price index that only looks at prices that are relevant to the typical consumer. There's also different price indexes. There's the producer price index that looks at prices of goods that are relevant for manufacturing. And so there you may have, things like the cost of capital goods that are completely irrelevant for a consumer, but for producers, they're more relevant. So there may be many different measures of inflation depending on what price index you're using, okay? But they all give you, in some sense, the average increase of some subset of prices in the economy. Okay, now, there's a few things I want to have a little bit of a conceptual discussion. Now we had a bit of a technical discussion about price indices. Now I want to kind of help you understand a little bit what are the big points to understand about the discussion when there is inflation in an economy, okay? The first point I want you to understand in terms of an economy in monetary units is that the price level, in some sense, is irrelevant, okay? And to understand what we mean by that, well, is that it just simply means we're free to choose the units, okay? And to illustrate that, let's suppose that we're going to change the units of the economy from dollars to cents. So now when you go to the store and you want to buy a soda can, instead of costing 2, now it costs 200 cents, okay? But your wage, you were making $15 an hour, now you're making 1,500, and everything gets multiplied by 100. What happened to that economy in real terms? Nothing happens. the cost of everything relative to everything else is the same. Your purchasing power is the same. Nothing has changed. It's exactly the same economy. We just express it in different units. So to say the price of something is 2 really doesn't have a lot of information in it of itself. What matters is what is the price of something relative to something else, and that's what we should focus on. So we are free to choose one unit, the unit of the economy. Okay. So following that kind of first point, the second point is that there is some particular prices that are important. In particular, what is important is what happened to the growth of, for example, your wage relative to the average growth of prices in the economy. And that's what, or another way of saying that is what really matters when you're thinking about your wage. If I tell you, I'm going to pay you $10 per day, in some sense, that's not enough information. What matters is what is the purchasing power of your wage. And so instead of expressing your wage in nominal terms, which will be $10, we're gonna define what we call your real wage. What is your real wage? Well, once again, as I said, this distinction between nominal and real variables keep coming in economics, and it's essentially a measure of the purchasing power of your wage. Okay, and so how much can you buy with your wage? That's what matters. And if you want to understand this a little bit better, let's do a simple example. Let's suppose that your wage is $10 per day and the price of bread is $2 per loaf. Then instead of saying your wage is $10, we can express your wage, instead of expressing it in dollars, we can express it in loaves of bread. And so your wage, notice for that we need an information not only on how much money you're getting paid, but also on the price of bread. So in some sense, this is a relative price of your time in terms of bread. And so that means your relative wage would be 5 loaves per day. We divide the $10 by the price of bread. It tells us how much bread you can buy with your wage. Does that make sense? Now, going back to the previous point that the number doesn't matter, let's suppose that now I tell you I'm going to pay you $20 per day. But let's suppose also at the same time the price of bread is $4. Notice that if we double your income in dollars, so we double your nominal wage, and we double the price of bread, your real wage is still 5 loaves per day. So your real wage hasn't changed, the purchasing power. So in some sense, the purchasing power is a race between 2 horses. What's going on with your nominal wage and what's going on with the price of bread? Okay. Now this is has a lot of implications. Now more generally, we can illustrate that with an approximation. So when we will look at what is the percentage change of your real wage? Well, the real wage is the ratio of your nominal wage and the price of bread. And it is a mathematical fact that we can approximate this as the percentage change of what is upstairs, your nominal wage, minus the percentage change of bread. And the percentage change of bread is your inflation. So in some sense, we want to know what happened with the real wage in an economy. We can use the approximation of, okay, let's look at how much more are you getting paid minus what was the inflation rate in that economy. Okay. Now, you may think all of this is boring. Why do I care about this? But this formula right here is the reason why we're meeting today via Zoom and we're not meeting in person. Okay. Now, more generally, let me just say we can define the more broadly rather than looking at bread, because maybe sometimes people don't like to just eat bread. We have a more relevant measure of all prices that are relevant. So the real wage we may define as the ratio of the nominal wage and the consumer price index. And so with this formula, what we get is that the percentage change in the real wage can be approximated by the percentage increase in wages minus the percentage change in the CPI, which, by the way, the percentage change in the CPI is what is the inflation rate. And so the purchasing power growth is the growth in wages net of the inflation rate. Okay. And so if we go back to look at the inflation rate and we see that, like, remember in the time series, we just look at, I just showed you this number here, the percentage, the inflation rate was about 2% for a long time. So the implication of that is that if you want to keep the purchasing power of your wage fixed, or in other words, you want to keep the real wage constant, you gotta increase what you pay people by about the same amount, by about 2%. And so for a long time, wages were increasing about 2% per year. Inflation was 2% per year. That's what we call wages were adjusted by inflation to keep the purchasing power of the wage constant. Now, here comes COVID. During COVID, as we will discuss, the central bank prints a lot of money, creates a lot of inflation, makes inflation go up to 8%. Now you have 1 year of about 10% inflation. What do you think people's response is going to be? Well, if they still have a wage increase of 2%, that means the purchasing power of their salary is going down by 6%. The real wage is going down by 6%. Does that make sense? So what do people do when they see periods of high inflation?
They ask for more wages.
They ask for higher wages, and that's exactly what we're seeing, all these strikes. We had the TA strikes, we had the federal worker strikes, we have today the transportation strike, we had the strike of the, in Hollywood, in the US, about the, people writing, in Hollywood. We had the strike of the port workers last year. All of these strikes have been taking place because there have been an increase in inflation. That increase in inflation means people are asking for more growth in wages to compensate for that. That leads to negotiations, then that leads to strikes. So this formula here and all the strikes we're seeing have to do with the increase in inflation that we've seen in the previous data I show you in the last few years, especially in 2022. And so now we're trying to, and different unions are trying to adjust the nominal wages to compensate for that inflation. So this idea that in order to keep the real wage constant, you have to adjust the nominal wage by the inflation rate is called indexing, okay? And indexing is kind of like a two-edged sword. On the one hand, you want to have indexing because otherwise people are getting paid less and less. On the other hand, indexing may be like as we will discuss in a second, it may be a way in which you create even more inflation. Okay, maybe like a problematic. So let's illustrate what we mean by indexing. Okay, so indexing essentially says if you live in an economy with high inflation, we're going to adjust your wages by the rate of inflation. So let's say your wage in 2022 was $1,000 per month, and inflation in 2022 was 10%, then your union will go and say, hey, we want a 10% increase to compensate for the inflation that we have. And then that means your wage in 2023 should be 10% of 1,000 increase, so $100 increase, and so it will be 1,100, okay? And this will mean your purchasing power in 2022 and 2023 will be approximately the same, okay? That's essentially the process that is going on right now. Now, this doesn't only happen with wages. Another place where there's indexing has to do with rent. Anybody rents here? If you rent, you know that sometimes the landlord wants to adjust what you pay in terms of inflation. So when inflation was 2%, then the landlord was allowed to increase rent by 2%. So that the real rent, the rent in terms of goods, as opposed to the rent that you pay in monetary terms, was constant. Because it's not the same to pay $1,000 of rent when the price is, of bread is $1 than paying $1,000 rent when the price of bread is $10. The price of your rent in terms of bread is very different. In one case, you're paying 1,000 loaves of bread rent. In the other case, you're paying 10 loaves of bread. So even though in dollars you're paying the same amount, the real rent, your rent in terms of goods, or a basket of goods, if you're using the CPI, is very different. The only difference with this one is that now the indexing is going for the landlord to keep the what you pay constant. So it can work in both ways, indexing. Okay. So once again, if you pay $2,000 per month, and the cost of a representative basket of goods is $1,000, then your real rent is about what you're paying is the equivalent of 2 representative basket of goods. And then the growth rate of your real rent, which is 2 basket of goods per month, will be determined on how much you're paying in dollars, the growth rate of this, minus the inflation rate, the growth rate in the cost of the basket of goods. It's the same idea. Okay. So the real rent, the growth rate in the real rent is the nominal growth minus net of inflation. So yeah.
If there is a deflation, then will the rent and wages decrease?
It's the opposite. So if you have some kind of indexing, then that means that if there is a decrease in prices, then the real rent should decrease, correct? Now, you may ask whether this happens in practice, but we will see, or we just saw in the data, deflation is relatively uncommon for reasons that we'll discuss in a little bit. So deflation is somewhat uncommon. But conceptually, indexing will mean that, yes, if there is inflation, then the nominal rate must go up. If there is deflation, in order to keep the real rent constant, you should pay less nominal rent. Correct.
Right, thanks.
Now, the point to notice here is that, so if you've been following a little bit what's going on in BC, you will see that inflation, so in the real world, things are more complicated because, as I showed you, inflation in 2022 was about 8-9%. And before that, BC had a law by which you were allowed to index rent. So if inflation was 2%, you could increase rent by 2%. If it was 3%, you could increase by 3%. And then a little bit, I think it was in 2018 or 2019, the law was changed. And then it was only allowed to increase rent by 2% per year. And now, obviously, 2% seemed like a reasonable number when we were in a low inflation regime. But then, COVID came along, and then we had inflation shoot up to 8-9%. And so now, when you have 8% inflation and you're only increasing rent by 2%, what you're seeing is a reduction in the real rent by 6% approximately. And so that's actually good for the people renting, but it's bad for the landlords. And so what ends up happening is the government allowed a one-time exception in 2023 for rent to go up by 3.5%. So this is another example for those of you who may be wondering, why the heck am I taking this class? This is the kind of thing that affects your rent. So you should be able to understand how this indexing process works, because for this reason is that you will see your rent go up by 3.5% in 2024, as opposed to 2%, which is what is set by law. And you can see that the 3.5% really is actually good news for you, because it means in real terms, your rent is lower, than it is going down, because the inflation over the same period was about 9%. The nominal rent is growing by 3.5%, so it means the real rent is decreasing by the difference. Okay, so the nominal rent hasn't grown enough to compensate for inflation. Why does that happen? Well, because the government wants to keep people being able to afford rent, and so it doesn't mind real rent going down. Now, where does this put a lot of pressure on? puts a lot of pressure on landlords who, as we will see later, has seen on the one hand an increase in the mortgage payments they have to do on their properties, but at the same time, they're not allowed to increase rent to compensate for that. So this has been good news for people renting, bad news for people who have a mortgage and rent their apartment. All right, now, one important point, so we understood the idea of indexing. Now, the important point to understand this, a key point in understanding the discussion about inflation is that indexing can create inflation. We say that indexing can be inflationary. Why is that? Well, let's suppose that now we have and that's why this point we're trying to make is the reason why the Central Bank of Canada and the Federal Reserve have acted so aggressively to try to control inflation. Because let's say that people now say, okay, now we're in a high inflation regime, so let's start indexing by inflation. So all our contracts in wages and rent are going to be indexed. You can see now, for example, the traffic strike that we're having today, they're negotiating. We want to have the strike happen because I believe it was some kind of supervisor. They were asking for a 25% increase in their wage. And then the other, the drivers, they maybe ask for a 15%. So wages will increase as a result of this indexing process. Rent will go up. Now, when so if you're like a business operating, let's say you're a restaurant, what's going to happen to you? Well, you're going to see the rent that you're paying for your restaurant is going to go up. You're going to see the wages that you're paying to your workers going up. So that means your costs as a restaurant will go up. And so some of that you can absorb as lower profit, but some of that you're going to pass to your consumers as higher prices. And so we can see that higher prices essentially means inflation. And so indexing creates this kind of like snowball effect where you have inflation, then wages and rents and contracts get inflated, and that increases prices, which in turn it creates another kind of round of increases in wages and rent, which in terms increases prices and so on. And so it means it may be difficult to stop inflation. So for this reason, in some contexts, indexing is not allowed to prevent this type of problem. It's like, okay, on the one hand, you want to be able to, so let's say right now in Canada, the central government is trying to control the inflation. So on the one hand, you want to allow workers to get paid more to be compensated for the fact that they've taken a 10% decrease in the real wage. But on the other hand, if this, is happening and wages are going up by a lot, that means that's going to make costs go up, and that means prices will go up too, and it may create more inflation. So there is this tension between keeping, wages, purchasing power, kind of in line with other prices in the economy, but that may create further increases in inflation and make the problem of inflation difficult. So at some point, this kind of needs to stop. It usually takes the form of workers being screwed and having to take lower real wages. And then real wages tend to. So there's one way of describing how this dynamic takes place, which is sometimes described as prices take the elevator, wages take the stairs. So the real wage in the meantime will suffer. Eventually, the wages may catch up down the line, but wages, employees will kind of refuse paying higher wages for as long as they can. So these are some of the issues associated with inflation and the kind of tensions that it creates. Is this idea of indexing more or less clear? Okay, another kind of related point that I want to make is that the expectations that people make about future inflation also are important. And this is also another problem of why controlling inflation is so difficult, because let's say you're going to sign a 2-year wage contract. And let's say the first year you get paid $1,000 and you're here in Canada. If you were signing this contract in 2019, and you look at the inflation data, you see, oh, the inflation rate's been about 2% for the previous 20 years. So, you know, I'm gonna ask for a 2% increase for my second year. That way I keep my real wage constant. Now, if you're looking at this in 2024, you may look at the data and say, hey, the inflation rate went up to 8%. So now I'm gonna ask for a 8% increase for my second year in the contract. And so for the same reason, if people expect inflation to last, they will include that in their contracts that they sign over long periods of time. And so for the same reason as before, now you will see that when people are signing contracts, they're asking for 10% increases, and that increases costs. The same thing with rent, and so that will in turn create inflation. So by the same dynamics as indexing, or another way of saying this is people expect inflation in the future, they will index their contracts to anticipate that. And if they include that expected inflation in their contracts, that will actually create increases in costs, which will actually create that inflation. Even if that belief was not true, that will become what economists sometimes call a self-fulfilling prophecy. Just because people believe or expect inflation, that in turn creates actual inflation. And so that's one of the very important reasons why the Federal Reserve and the Canada Central Bank wanted to act so quickly to bring the inflation down before and have the market participants and the people in the economy believe this increase in inflation is only a temporary increase, but it's not now it's not inflation coming here to stay at 10% forever, because if that happens, just people believing that may make it enough for us to be stuck in a situation where bringing inflation down becomes beyond the scope of what the government can do, because now it's entering the realm of what people have as expectations. And so how do you change the expectations? So this is an important point in economics in general, and inflation is a kind of one of the most important examples. Expectations about the future can have real impacts. We already talked about this in the context of the paradox of drift, and this is another example of this idea of this self-fulfilling prophecy, or the fact that people's expectations about the future can have an impact. Does that make sense? All right. Now, another element about inflation is that when inflation is expected, it most likely be included in the contracts, and it will have no effect in real variables. So if you expect inflation to be 10%, then you will anticipate that, you put it in your contract, and your real wage will be the same, and there will be no effect. Now, let's say you miscalculate inflation, and let's say you expect the inflation to be 10%, but inflation ends up being 15%. But your nominal wage only grows by 10, that means actually your real wage, because there was higher than expected inflation, your real wage would actually go down by 5%, because your nominal wage only grew by 10, you're indexing, but the real inflation was not the 10 you anticipated, but it was higher. So if inflation is higher than what you anticipated, that means the real wage will end up being lower than you had agreed upon in your contract, and that's essentially is a transfer that's good for the employee and that's bad for the worker. So that leads to a transfer or redistribution of wealth just because you anticipated the future wrong. And this is not based on any merit by the employee or any mistake on the part of the worker. It's just a bit of a random thing based on a miscalculation. Similarly, if you miscalculated the other way, if you assume inflation was going to be 10%, but it's only 6, then that will be a transfer. You end up getting a higher real wage, which is a transfer from the employee to the worker. It's not based on any merit of the worker, it's just somewhat random. And so this is what we call that unexpected inflation leads to somewhat random, not based in merit, redistributions of wealth. Okay. Now, to kind of make this discussion about inflation complete, we want to have a discussion a little bit about nominal and real interest rate. This idea that happens with wages also happens with contracts. And one important example of these contracts is loans. okay? And so we will discuss a little bit of the distinction in this context. So this redistribution of wealth due to unexpected inflation also take place in loans like mortgages or loans that take place over time. So it's a little bit more tricky than in the case of wages, but it's not that complicated. So let's take a moment to introduce. By the way, normally I would have made a break, but today, because this is online, I'm just going to keep going a bit longer, and then probably I'll take finish a bit earlier. I don't know if I'm probably not going to be able to cover all of the slides today, so we'll have to pick up next lecture. Okay. So what I definitely want to make sure I discuss is the distinction between a nominal and a real interest rate. Okay. So let's start with the definition of nominal interest rate. The nominal interest rate essentially is the percentage increase in the value of an investment or a loan, depending if you're a borrower or lender. Okay. So for example, if you buy a house for $500,000 and 1 year later the house is worth 600K, then the value of your investment went up by 100K. That's 20% relative to what you invested. So then the nominal rate of return or interest rate on your investment is 20%. You bought something worth 500,000, it went up by 20%. Okay. Similarly, from the point of view of a lender, if you borrow $2,000 to buy a new iPhone, and let's say they tell you the nominal interest rate on your loan is 5%, it means after a year, assuming you don't pay nothing back, what you owe, the size of your loan is the 2,000 plus 5% of your loan. So you owe the 2,000, this is called the principal, this is what you borrowed, plus the interest payment, which is 5% or 0.05 times the principal. So this will be 5% of 2,000, and we can just write down succinctly as 2,000 times 1 plus 0.05. The 1 represents the principal, the 0.05 represents the interest. 5% of 2,000 is 100, so it means after 1 year, your debt will be worth 100. It will be worth 2,100. Okay, so that's the nominal interest rate. How much what you owe in dollars has grown. Okay. More generally, we can write down this formula. We're going to use it that if the nominal interest rate, which before was 0.05, we call this R, and the amount you invest or borrow, instead of being $2,000, we call it M. So you borrow M dollars and you have to pay an interest rate R. After 1 year, or you could put M dollars in the bank and the bank will pay you this interest rate to you with the same calculation. After 1 year, you will have the M dollars that you put in the bank back plus the interest payment, which is the fraction R times M, or you would have M times 1 plus R. Once again, this term here, M, is called the principal. So this is how much you borrowed, and this is the interest. It's the penalty you're paying for returning the money 1 year later.
Hello.
Hello.
Hello. Just had a question. Why are we adding 1 to R again?
Oh, that's just simply another way of writing. If you factor out M, you notice the left-hand side is equal to the right-hand side. If you multiply M times 1, you get M. And then you multiply M times R, you get the interest. So this is just a way of writing this more succinctly. Instead of, if you go here, instead of writing 2,000 plus 0.05 times 2,000, you can write the same thing as 2,000 times 1.05.
Okay, I understand. Thank you.
All right. So now this is, as we saw, how much your debt is going to grow in dollars, but let's think about in terms of defining this in terms of goods rather than in dollars, or purchasing power of those dollars, which is what matters to us. And that leads to the definition of the real interest rate. So the real interest rate essentially is the percentage increase in the purchasing power of the amount of money you owe, or in the amount of money you invested. So let's do an example to illustrate what we mean by that. So let's suppose that you have $1,000 today, And today the price of a coconut is $2 per coconut. And so you're going to decide to invest this $1,000. What you're investing today is equivalent to 500 coconuts. Okay. So you invest this $1,000, which is today the equivalent of 500 coconuts. And let's say you're going to get a nominal interest rate of 20% of your investment. So after 1 year, you put $1,000 in the bank. What you get out is, using our formula, $1,000 plus the 20% interest. So $200, 20% of 1,000 is 200. So after 1 year, you have $1,200. Does that make sense so far? Now, the question is, that's all very nice, but in order to know what happened with the purchasing power, we have to see what happened with the price of a coconut. And so let's suppose the price of a coconut in the same year has gone up from $2 to $3. Now notice that when we invested this $1,000, that was enough to buy 500 coconuts. We put it in the bank, and 1 year later we get 1,200. But because the price of coconuts has gone up, now those 1,200 are enough money to buy 400 coconuts. So in nominal terms, the pile of money we have grew by 20%. We started with $1,000. Now we have 1,200. The growth rate of 20%, that's our nominal interest rate. But in real terms, we started with the equivalent of 500 coconuts and ended up with the equivalent of $400. So we had a negative real return. It went down by 100 coconuts. So the real return was minus 20%, even though the nominal return was plus 20%. Does that make sense? And notice
Yes.
what's going on here is that why are we getting such negative? Because here the inflation rate was 100%. So even though we had a nominal rate of 20%, we had an inflation rate of 100%, which was weighing down so much. That means the real return was actually minus 20 instead of plus 20. So the inflation rate made our real return be 40% lower than our nominal return. In general, we can find a relationship by doing a simple calculation between the nominal and real rate, which is essentially doing this same calculation just we did, but with formulas. Now, what is going to come next is not super important. I'll just do it once for you guys to see where the formulas come from, okay? In general, the formula we're going to get out of this calculation, which now that I'm thinking about it, I don't even know if I have this calculation here. So what we get is essentially the following approximation, which is the real return when we have low values is essentially the nominal interest rate net of inflation. So for example, if we have a nominal interest rate of 10%, and during the same period, the inflation rate was 8%, then that means in coconuts, what you invest in the bank will grow by 2%. So the real interest rate is approximately equal to the nominal interest rate net of inflation. So that means that if you invested in stocks during 2022 and you made a 12% return, you have to subtract from that the inflation rate of 8%, and your real return over 2022 was only 4%. Does that make sense?
Yes.
Okay. It's basically, this formula here is the same formula we use for the real wage, which had the percentage change in real wage was equal to the percentage change in the nominal wage minus the inflation. So it's basically the same approximation in this case.
Do we have is pi representing?
Sorry, I couldn't hear that. Can you say it again, please?
Sorry, is pi representing the change of inflation?
I think you asked if pi refers to
Yeah.
the change of inflation. Yes, pi here, thank you for pointing that out.
Okay.
Pi here is not associated with the circumference of the circle or anything like that. It refers to the rate of inflation. Thank you. Now, notice the same ideas apply. If you anticipate about the future to have 8% inflation over the next 10 years, if you sign a loan contract, then the bank, if they're going to give you a loan, they're going to have to include that in the loan. So they're going to have a nominal rate that is above that 8%. So they're going to include that expected inflation in the nominal interest rate to keep track of the, sorry, I had a bit of a spill my mate here. There. So they're going to have to include that in their contracts, which means they're going to be higher interest rates when people anticipate higher inflation. Similarly, we have the same phenomenon that we were discussing about. So expected inflation will lead to higher nominal interest rates. And if people guess wrong what the inflation was, for example, let's say you bought a house in 2021, the bank was not anticipating there was going to be high inflation, so they give you an interest of 2% for the next 5 years, but then inflation ended up being 8%. So the bank was anticipating 2% inflation, but there was 8% inflation. That means in real terms, what you owe is going down by 6%. The real inflation, the real interest rate is negative, which means the amount of money you owe expressed in goods is shrinking. Okay, and so unexpected inflation leads to redistribution of wealth. When you have inflation being higher than you anticipated, it means the real interest rate will be lower, and that's good. Good news for those borrowing and bad news for lenders. And the other way around, if you have lower than expected inflation, that means the real rates are going to be higher than you agreed. Higher real rates is bad for borrowers, is good for lenders. And this is particularly important when it comes to mortgages, because people take mortgages and that's a very high, important, significant fraction of of a family's wealth and a family's monthly expenditures. And so, those redistributions can be quite significant for an economy. Does that make sense? Is this idea of how with this notion of indexing also applies to loans and also applies to borrowing and lending over time, and that we can also define, like we define nominal and real wage, nominal and real rent. There's also going to be a nominal and a real interest rate, where the real interest rate is just the nominal interest rate net of inflation. All the same other ideas will apply. Okay. All right. Any questions so far? Okay. Now, let's discuss a few of the costs that inflation can have. We already discussed the unexpected redistributions of wealth. Now, unexpected redistributions of wealth essentially are good for some people, bad for others. In addition to that, there are also costs to the overall economy that nobody gains from. Okay. Now, one of these is menu costs. If you want an example of menu cost essentially refers to the fact that when you have inflation, you have to be renegotiating prices more often. And that, the typical example is that you have to, or if you're a restaurant, you have to print new menus more often, or if you're a pho place, you can just cross it out with pen and put the new price there. Eventually you run out of place, you have to print a new menu. That's a cost, it's a waste of resources. Now, this idea of menu cost can be interpreted more broadly in an economy, and you have to look no further than today to find the menu cost. The fact that we have to renegotiate wages more often, it means that we're going to have to weight society's resources in negotiations. They're going to take time. There may be strikes. There may be other things that happen. So all of those are examples of menu costs, of the fact that we have to renegotiate prices more often, and that creates costs that are just a waste of resources for the society. Now, another example of the costs that are created by inflation, classical costs, called shoe-leather costs, which means when you're in a high inflation environment, you have to kind of make more trips to the bank to get money, because when you are in a high inflation environment, in some sense, because money does not, so the nominal interest rate of money is zero. Money does not pay you interest. So it means the having money has a cost. Or in other words, the real return of money is always negative and equal to the inflation rate. So the higher the inflation rate, the more costly it is to hold money. In other words, if inflation rate is 2% per year, if you have a $100 bill, after 1 year, you've lost 2% of that purchasing power. If you have a $100 bill in an economy where inflation rate is 20% per year, after 1 year, you've lost 20% of the purchasing power. So 2% may not be too much, 20%, it means a lot. And so if you're in such an economy, rather than keeping cash in your hand for a long period of time, you will make more extractions. Okay, so that's referred to as shoe-leather cost. Now you have to make more trips to the bank, and that's gonna waste the leather under your shoes. Obviously, that's typical economist sense of humor for just referring more broadly for cost of time associated with having to transaction costs associated with being in a higher inflation environment. Now, in the extreme, you have hyperinflations. As an Argentinian, we're an expert on that. Some examples include the Weimar Republic after World War I. Germany signed kind of this kind of I forgot the name of the agreement, but it was after World War I. Germany signed such a disadvantageous agreement that it was bankrupt, and it had no other way of financing itself but through printing money and creating a lot of inflation. And so essentially it led to a point where essentially workers have, so when you're in a hyper, remember what we just said, inflation. So this kind of like the extreme example of this shoe leather costs, where prices are growing so fast, so which means the cost of holding money is so large that people are just trying to get rid of money. So workers have to be paid twice, because and as soon as you get paid, you have to run to the supermarket to buy goods, because if you waited until the afternoon, your wage could, your purchasing power. So imagine you're being paid with something that is losing value as you hold it at a really fast rate. So as soon as you get paid, you just want to go and get rid of it. People are getting paid with, you can see like a cart full of cash, and this cash, you're not rich, you can buy nothing with it. An example of this is Zimbabwe, where you had starving billionaire with $100 billion dollars from Zimbabwe, you could buy 3x, right? And eventually what happens in this extreme hyperinflation is that nobody wants to use the money, because the money is just losing value so quickly. So people just want to trade it for goods, want to trade it for other currencies, like stronger currencies like US dollars or euros or whatever, gold, that hold value. Because one of the, as we will discuss, one of the problem with this is that money loses its purpose, and people are just trying to get rid of it. Essentially, the money is collapsed altogether. Nowadays, Zimbabwe, after this hyperinflation, had to abandon the use of its domestic currency. So this kind of like the extreme example. Right now, Argentina is at the verge of entering a hyperinflation again. And so right now, people are like, my sister was just in Argentina. She was telling me, like, you go to the restaurant and you're having to pay the bill. And also what the government did, because they didn't want to recognize that there was inflation going on. So one of the problems you have with inflation is like, now you have to keep printing. And like here you have a $100 billion bill, right? But the Argentinian government didn't want to do that, because that would be recognizing there is inflation. So you have to pay with like a lot of bills. So you go to a restaurant to pay, you have to take out like a suitcase full of bills, and it's just extremely unpractical. So also some of the costs you encounter in kind of the extreme version of these high inflation environments. Okay, this is not fun. I was very young, but I lived through hyperinflation, and yeah, it didn't end up well. It ended up with the country being at the verge of collapsing. So no fun thing. Here is some historical examples. Question.
In the Germany scenario, could you just explain briefly why the prices like rose in the afternoon? Like why they just rose so quickly
Well,
kind of there?
We'll discuss this in more detail when we discuss monetary policy, but essentially what happens is that the government is printing a lot of money. And so if you imagine like this is the typical example, imagine you're playing a game of Monopoly and you have the same properties, so the real economy is the same, but now you're playing with double the amount of bills. Well, what's happening is the value of those bills in terms of property has to go down. And that's what price increases mean. It means the value of that currency relative to other goods and services is going down at a very high rate because more and more bills are being produced. And people don't want those bills because they know they're going to lose value very quickly, so they're trying to get rid of them. So it's essentially you are producing something at very high rates that nobody wants, and people are just trying to get rid of it. And the more people try to get rid of it, the more it loses value. So that's essentially how the dynamic works. We'll discuss this in a little more detail when we talk about monetary policy, but that's the flavor of it. So here's some extreme examples. Here you have, starting in Germany, the highest monthly inflation rate was about 30,000%. That's about a 20% inflation rate per day. And that means in about 4 days, prices double. So this means you're in essentially exponential growth of the price levels, and it's just insane. Yugoslavia after the war in '94 had monthly inflation rate of about 65%. Zimbabwe in 2008, at some point it just stopped measuring, but it was about 100% per day. So it means prices are doubling every hour. And then Hungary after World War II. Essentially, the monthly inflation rate was 10 to the 16. I don't even know what that number is. I guess it's like 1,000 trillion, so a quadrillion, or whatever. So that means essentially the daily inflation is about 200, and it takes about 16 hours for prices to double. So that's why as soon as you get paid, you run to the store and you get rid of all those pieces of paper and trade them for goods that you can actually eat. So I think I posted a little video about the case of Zimbabwe that illustrates some of this with real world stories. I encourage you to watch this from Canvas. Okay. Now let's finish our discussion with a little bit of what happens about deflation. And so deflation, as we will see, can also be problematic in addition to inflation. Not only you have the same problems in terms of unexpected redistribution of wealth, but the problem is that if you expect, this is kind of related to the paradox of thrift, if you expect prices to go down in the future, then it means your purchasing power is going up over time. So that means that now holding $1 in some sense has a positive return. So people don't want to spend, they want to hold their dollars. And if nobody spends, that can be recessionary for the economy. And so that's why deflation can lead to these recessionary traps where there's no spending. And it's very difficult to get out of, once again, because of now you have to break this expectation. Now notice that if people are not spending, that will put more pressure for prices to go down. And so this kind of like sometimes called a deflationary spiral, where people are not spending because they anticipate deflation, and that in turn creates more deflation, which reinforces the expectation not to spend, and so on and so forth. So if you want to scare a central banker, go and whisper in their ear deflation, and it will freak them out. So the point is deflation can be pretty bad. high inflation can be pretty bad. What we really want is price stability. And price stability, because deflation is so dangerous, we don't want to have a 0% inflation, which would be price stability, but we want to have sometimes what is called inflation target of 2%. Okay, so this is as we saw in the data, that's been the Federal Reserve have been pretty successful of doing that for quite a period of time, of for the reason of the expectations, make everybody believe that the Federal Reserve has a target and a commitment of keeping inflation at 2%. That will fix the expectation. Everybody in the economy will index their contracts by 2%, and that will kind of lead to a stable situation where prices are, you have a little bit of inflation, but not too much. It doesn't have much of a cost, and it gives you a little bit of leeway to stay away from deflation. That makes sense? All right. Okay. So we have a little bit of time to start our next discussion of unemployment, but I think I'm gonna finish here, and I'm gonna save this for next time. So next time we're gonna start discussing about unemployment, and we'll start a discussion about chapter 9. Okay, so I feel like taking 1 hour and a half, so I'm gonna stop the class here. We'll continue here next time. Are there any questions so far?